Welcome to the Deep Dive, where we break down complex tech and give you the inside take. Today we're looking at a really central piece of broadcast infrastructure. It's the Thor Broadcast H-16QAM-IP.
And that name, it really signals a huge shift in the industry. Our mission today is to get into not just what this box does, but why it's such an essential gateway for modern media. We're talking about how you take massive amounts of traditional RF radio frequency signals and turn them into flexible IP streams.
Okay, so let's frame the problem it's solving. Broadcasters are still getting signals from everywhere, right? Cable, satellite, over the air.
All legacy formats, yeah.
And this device, it sits in the head end and basically has to make all of that old school tech play nice with modern AV over IP distribution. It's like a universal translator.
Exactly. And if you look at its inputs, that versatility is, well, it's the whole point. It has 16 completely independent tuners inside.
16.
16. And that capacity lets it handle almost any signal you can imagine. You've got DVB-S and S2 for satellite, ATSC for, North American over the air.
And a legacy cable, too.
And DVB-C QAM for the cable systems. It's really designed to swallow any flavor of RF you throw at it.
But the really mind-blowing part for me is the output ratio. It takes those 16 physical RF channels and turns them into 512 IP streams.
Up to 512, yeah. Specifically, single program transport streams, or SPTS. That huge jump in segmentation is everything.
So what exactly is an SPTS?
Think of it as just one single TV channel, one feed all by itself, ready to be routed individually over a network using standard protocols like UDP or RTP.
So you get this incredible granular control over which specific channel goes where.
Precisely.
The sources also mention a secondary output, an MPTS. What's the point of that if the SPTS is the key?
Right. It also generates one multi-program transport stream.
Yeah.
You can think of the MPTS as more like the old cable bundle, one big stream with lots of channels packed inside. It's mainly for compatibility with certain downstream equipment.
Got it. And what about the ASI inputs?
Those are for bringing in other high-bandwidth video sources that are already in a digital format.
Yeah.
Just adds another layer of flexibility.
Okay, wait. If you're taking 16 signals and exploding them into 512 perfectly synchronized streams, that must require a massive amount of internal processing. This can't just be a simple converter.
Oh, absolutely not. It's running a really sophisticated engine. That's where the value is. To keep that broadcast integrity, it's running 16 groups of processes at the same time.
Like what?
Multiplexing to combine the data, scrambling for encryption, and then QAM modulating to get the signal ready for cable transmission if needed.
And to guarantee quality, they mention some very specific controls. The first is accurate PCR adjusting. Why is that so critical?
PCR program clock reference is basically the digital stopwatch. It ensures that the audio, video, and data for every single one of those 512 streams stays in perfect microsecond level sync.
If that drifts, you get
Right.
what? Glitches. Audio lag.
You get a broken picture, audio lag, the whole thing falls apart. It's absolutely vital.
That makes perfect sense. And they also let the operator edit the PSII and VCT. That sounds like controlling the user experience.
It is. That's your program and service information. Editing that and the virtual channel table means the broadcaster controls the electronic program guide, the channel names, the channel numbers, everything you see as a viewer.
And all of this is backed up by a high-performance index, an MER of 40 dBAs or more.
Which is a very high standard. It just means the output signal is practically pristine.
So if we pull back to a real-world application, this lets a broadcaster be incredibly flexible then.
That's the strategic payoff, the ability to mix and match. You could take free over-the-air channels and convert them all to IP, or, say you're a hotel, you can grab those local channels and seamlessly inject them into your existing cable lineup.
And it's all managed through a web interface, which makes it dynamic. You can rearrange your channel lineup on the fly.
Exactly.
So we've really unpacked an essential piece of the puzzle here. It's a complex transmodulator handling huge frequency ranges, all crammed into a tiny 1RU box.
The real nugget to take away, though, is what that 16 to 512 conversion really means. It is pure digital segmentation.
Right. So here's the thought to leave you with. If a broadcaster can turn 16 physical signals into 512 flexible IP streams, what does that level of segmentation unlock for the future of custom content? That capability means an operator could deliver micro-targeted channel packages or even specific ads to different TVs in the very same building all at the same time. That's the real power this gateway technology enables.